Welcome to Let's Talk Micro. Hello, everyone. Welcome to another episode of Let's Talk Micro. I hope you had a great week. As always, Let's Talk Micro it's available on Apple Podcasts, Spotify, Google Podcasts, Stitcher, TuneIn Radio, Pandora, GoodPods. Whatever you listen to your podcast, you can find Let's Talk Micro. And I said it through my social media, but Let's Talk Micro it's available now on the Ghana app. That's Gaana. So for those of you listeners that are in India, you can find Let's Talk Micro in the Ghana app, Gaana. I am on Instagram as Let's Talk Micro, no apostrophe, and on Twitter as Let's Talk Micro 1. I'm also on LinkedIn. My name is Luis Plaza, so you can find a picture of a profile picture, and I like to post updates of the episodes. So on social media, I put pictures of organisms. I give updates as to when the next episode is coming out. So as always, if you want to leave feedback, go ahead and subscribe, download episodes, or just give topic suggestions. So any feedback, topic suggestions, they're always welcome and appreciated. And if you haven't listened to the last week's episode, go ahead and do so. It was a great interview with Dr. Alan Wu. Like I said, he's a professor of laboratory medicine at the University of California in San Francisco and a co-lab director at the Zuckerberg San Francisco General Hospital. This was a little bit of a different episode. I typically interview professionals in the microbiology or laboratory field that have made some sort of publication. And of course, Dr. Wu has an extensive experience. He has contributed to laboratory medicine in many ways. As of his career includes teaching, publications, etc. But the reason that he came to this episode, he has made other contributions, and one of those are he published some books about the lab that are short stories, published in fiction style, but based on real cases and even people. I have to say, I checked out the one about microbiology, and it was very interesting. Also, one way that Dr. Wu is trying to bring awareness about the lab is by creating a TV show that accurately portrays the lab. Can you imagine that? Those of you, I don't know, like I like to say myself, I'm a fan of television. I grew up watching a lot of television, a lot of film. I have seen many medical shows, like for example, ER, comedy, like Scrubs. I have seen a lot of crime scene investigation. So of course, these shows are very interesting and they portray medicine, but you haven't really seen one about the lab. So at least, something that accurately portrays the lab. And like I told Dr. Wu, this is definitely a great effort on his part. And I look forward to it. So there you have it, something a little different from what we see. Typically we do see publications, textbooks in the lab. That's about it, publications about some research, let's say some organisms, some tests. But to get to see the lab first in books, like short stories, like those of you that like to read. So seeing it like fiction style is very interesting, very cool, I have to say. And now getting to see it on the TV, something that we as medical laboratory professionals can relate to, in my opinion, is very awesome. So I definitely look forward to listening to to watching Dr. Wu's show. And if you want to check out his books, I mentioned in the previous episode, go to a search engine, and type Dr. Wu, lab book stories, and you should see the list of books. There are about 6 of them. So go ahead and check them out. So on today's episode, I am going over techniques and media that you should keep in mind and use if needed. Like I said before, as part of this show, I like to explain biochemicals, organisms, I talk about media, and I like to present it in a simple form that is easy for a student and a professional to understand. So that's one of the goals. So, and I also like to talk about my experiences. So on the next episodes, I'm going to talk about things you can do when you are like missing supplies or you having trouble isolating an organism. So I said this before, with the pandemic, we have faced issues like supplies, like shortage of supplies. And this is because, with COVID, many companies, they stop or reduce making certain products to focus more on COVID tests. A great example is those of you that use the Gene Expert systems. There was a huge shortage with the chlamydia and gonorrhea PCR because they moved their focus to make COVID tests. So that was a tough time as far as getting supplies. We were getting, they were on back order. Test results were delayed. So if you work in a large facility, you probably saw a lot of samples being held back. Granted, they have a long stability, but still, producing a result that late, it's not great. So we just had to deal with what we had at the time. So definitely, media also was affected. Manufacturers maybe slowed down the, making the media, or they kind of stopped making it for some reason. So you had to move to like a different vendor. Those of you that order supplies definitely know what I'm talking about. So that's from the point of view from the one that's ordering the supplies. So as a bench tech, you also saw the outcome of those supplies being delayed, right? You felt the frustration of not having the tools to perform your job. So what do we do if we don't have, let's say, PEA agar or CNA, and we are unable to isolate that gram-positive cocci? Cultures, they vary on their source. Depending on the source, you have a lot of flora in some areas, and some other sources, they're expected to be sterile. So what you get on the cultures, it's a combination, right? Depending on your source and what kind of infection you're having. So, and I touched on this before, but you get some sources, let's say like blood cultures, that they tend to be monomicrobial. And what's that? It's one organism is present. But what about sources that are polymicrobial, that you have multiple organisms? For example, those of you that work with wounds or respiratory cultures have seen how many organisms you can recover. Some of those wounds, for example, let's say like those patients that are diabetic and their wounds are not healing properly, can have typically 2 to 3 enterobacteriales and 2 to 3 non-fermenters. So it is definitely not uncommon to see one of these wounds with, let's say, E. coli, Klebsiella, along with Pseudomonas aeruginosa and Pseudomonas. I have seen some with that combination, along with also, alkaligenes, Shigella. So what about if we are having trouble isolating a Pseudomonas aeruginosa or a Pseudomonas? What do we do in those cases? Well, to answer that, today I am going to talk about things that I have experienced and done. Also about things that you should be aware and not assume. Remembering, assuming things in the lab is a big no-no. It is also very dangerous. You can put your patient at harm. We are scientists, and we prove that by, we prove what we have by performing the appropriate testing and following all the protocols. Right? Even though if you look at a culture and you're experienced enough that you definitely recognize the bacteria, and some of them, even at the beginning of your career, you can get good at recognizing, like you can recognize a Staph aureus or an E. coli. And even though you can recognize it and you know what it is, you cannot just go ahead and call it, right? You have to do testing before you can say, this is an E. coli, this is a Staph aureus. So yeah, you can presumptively identify it and maybe not do like a Vitek or a Molotov if it meets a certain criteria, but you still need to do the testing. So we always need to do appropriate testing and follow all the protocols. I like to say this, it is always good to review your media and know its components. And keep in mind that once you isolate the organism, prior to performing an ID or susceptibilities, the organism needs to be on the accepted media for it, or one that your lab has validated, right? When you look at your Vitek, let's say, it tells you that you can set up, let's say, gram-negative susceptibilities on blood agar, E. coli, for cocci, blood agar, So things like that. So if you recover your organism on a media that is not accepted for performing ID or susceptibilities, you will need to subculture the organism to that appropriate media. And when in doubt, always refer to your CLSI or your manufacturer's acceptable media. Always do that. And if you have trouble finding the resources, go ahead and ask a lead tech, a supervisor, your director. So make sure you ask someone, assuming it's a big no-no. So let's go ahead and talk about PEA. So what is PEA? I have talked about media before, but PEA is a medium that is selected for gram-positive organisms. It has sheep's blood agar and phenylethyl alcohol, which inhibits the growth of gram-negative organisms. And in the lab, you typically see it with your wound cultures and abscess cultures as part of your standard setup. It is a great medium when you have a culture that has mixed organisms and you want to recover a Staph aureus, an Enterococcus, a strep. This is especially true when the culture has produce. As you know, produce swarms, not always, but most of the time it does. So when that happens, it is hard to recover other organisms, especially ones that are gram-positive. So that brings the question, what do we do, if you have a blood and chocolate agar plate that it is all swarmed over, and your gram stain says that you have 2+ gram-positive cocci? Well, we look at the PEA plate, and if the culture doesn't have one though, the setup of that culture didn't include a PEA, then you go ahead and retrieve the original specimen and set one up. You can also do what is called a PEA sweep, where you swap the first quadrant of that sample, of that culture, of your blood plate, and then inoculate a PEA and see if you recover gram-positive organisms. And this PEA plate, it has blood agar, and as you have learned, blood is what we use as a differential. Blood agar, it's a differential agar that we use for hemolysis, right? The lysis of RBCs with your alpha, beta, and gamma. So as a student, you might be thinking, can we use the PEA plate for hemolysis? And the answer, to detect hemolysis. And the answer is no. We should definitely not use it. It is misleading. Some organisms that are hemolytic on PEA are not hemolytic on blood agar. And a great example of this is Enterococcus faecalis. Enterococcus faecalis, and I will talk more about it on a different episode, but just to touch on it, it's a gram-positive cocci in chains that is catalase negative and PYR positive. And while most of the time it is gamma hemolytic, it can be beta hemolytic as well. So at some point in time, I think most of us have encountered that we have a beta hemolytic colony, and we think that is a strep, and then we do a PYR, and it is positive. And then you go ahead and do the typing, and it is negative for A. Or the other way around, we do the typing for A, B, C, F, and G, and it is negative, but the PYR is positive. So we have encountered in the lab beta hemolytic Enterococcus faecalis. But however, when you have it on PEA, a lot of the time it looks beta hemolytic, but then on blood agar, it is gamma hemolytic. Other organisms that can look beta hemolytic on PEA, but yet not have hemolysis, are some species of coagulase negative staph. You can have sometimes, staph epidermidis, that it can look beta hemolytic on PEA. And then if you sub it to a blood plate, you see that it is gamma. And nowadays, with the MALDI-TOF, it is easier. You see a suspect, beta hemolytic colony. And then you go ahead and do the MALDI-TOF. And then based on that, you proceed. So if you need to rule out, let's say, Staphylococcus lugdunensis, and then you see the beta hemolytic colony on PEA, do your MS, and it comes back as a staph epi or a staph hemolyticus. So it makes it easier. But just on those labs that you don't have a MALDI-TOF, that you have to either subculture things to rule it out via Vitek or another instrument, You have to keep in mind always that some organisms, that can be beta hemolytic on PEA, but not on blood agar. So now that I have talked about PEA and I said that, it is selective for gram-positive organisms, the question comes to mind, right? Can gram-negative rods grow on it? Well, the answer is yes. And actually, E. coli and Proteus can grow on it. And sometimes, other gram-negative rods. However, the colonies are smaller and the growth sometimes is restricted. So, and this comes to, this connects to things that I have said before that don't assume about agar, right? So you can have gram-negative rods growing on PEA, and this is why the gram stain is such an essential tool. You might not want to do it, but it will save you time. It will save you from getting in trouble. And most important of all, it will save you from causing harm to the patient, which is what we do all of this for. So remember that. But I want to talk about PEA for one main reason, and it is that PEA is a great medium to recover Pseudomonas aeruginosa. So for your students out there, what do you remember about Pseudomonas aeruginosa? It is a gram-negative rod, oxidase positive. Is it part of the Enterobacteriales or Enterobacteriaceae? Well, the answer is no, right? It is oxidase positive, and all Enterobacteriales are oxidase negative. It also does not ferment glucose. So PSA, Pseudomonas aeruginosa, is an organism that is ubiquitous to the environment, and it is opportunistic. It is also nosocomial. You remember nosocomial, right? Hospital-acquired infections. It also has a high level of intrinsic resistance than, let's say, the Enterobacteriales. So this is an organism that in the lab, we need to rule out. Those of you that work with cultures in the lab, you see that sometimes, depending on your facility, if you have 2 to 3 organisms, let's say like 2 to 3 Enterobacteriales, you can go ahead and mix the culture, report as mixed enteric flora, or let's say mixed gram-negative rods, mixed gram-negative, gram-positive flora, especially depending on the source, right? If you have like an abdominal source, a rectal source, if you have Enterobacterialis, if you have 2 to 3, you typically mix it. And then you have some organisms, like, like you always work up, like your Staph aureus, your beta streps, your Pseudomonas, your Pseudomonas aeruginosa. So those, you work them up regardless of what you have, and then you can mix the other ones. So what if you have one of these type of cultures that you have 2 to 3 gram-negative rods, some gram-positive cocci, and then you suspect a Pseudomonas aeruginosa, and you have to report Pseudomonas aeruginosa. So what do you do if you have so many gram-negative rods that are crowding your McConkey plate and too many organisms on your blood agar plate? Yet we see something metallic crowded on the blood plate, and we do an oxidase and it is positive. So what do we do? I mean, we need to rule out a Pseudomonas, so you're trying to sub it out to a McConkey. You drag some other of the gram-negative rods. It still looks messy. The same with blood, especially true if you have a Proteus. You keep bringing that Proteus with you, if you grab it from the blood plate. So go ahead and look at your PEA plate. Look for some small white colonies. If you see those, do a gram stain. If they are gram-negative rods, do an oxidase test. And you're on the right track. So at this point in time, let's say even if you have a moldy-tough and you go ahead and put the colony and it tells you that it is a Pseudomonas aeruginosa, you cannot use that for an ID or susceptibilities. So at that point in time, you will have to grab those white colonies and sub them to a blood agar plate. It is always good, if you don't have Proteus involved, that to sub organisms to gram-negative rods to a blood agar plate. A lot of times, on the McConkey, they look very similar, especially non-fermenters, non-lactose fermenters. So it is best so you can see on a blood agar plate and do biochemicals, which helps with identifying them. So another way to go about this is that you see, let's say that you're looking at that same culture, and you have you see maybe something metallic, something greenish, and in that mix of organisms you touch for an oxidase and it is positive. Then go ahead and, instead of doing a blood agar plate or a McConkey plate, go ahead and sub that colony to a PEA plate. And then you can get more differentiation. You can go ahead and look at that PEA plate, search for those white colonies, and then go back and sub it to a blood plate. Granted, this is not ideal because it delays care. Because if you cannot get that Pseudomonas on the first day or the second day, you get that extra day where you are plating to a PEA if you don't have one already, and then another day to sub it to blood. So it delays things, but these are things that these things that I'm talking about, they are atypical. So it is just tools that you can use to recover that organism. Ideally, your infection is monomicrobial, or you have enough separation where you see that Pseudomonas right away, and you can go ahead and work it up or sub it out if you don't have enough. But this is something that you need to keep in mind when you are trying to rule out a Pseudomonas aeruginosa. So what to take from this information? Well, one, that PEA, while it's very helpful for isolating gram-positive organisms because it is selective for them, it can be misleading as far as hemolysis. To make sure that, keep that in mind, that some organisms, they look different on PEA than they look on blood agar. And also, to take from this is that this is a great medium to recover PSA. So when you're having trouble isolating a Pseudomonas aeruginosa, you can use this medium to at least get it isolated, and then you can subculture it to the proper media for susceptibilities and biochemical testing. So always, if you have a PEA in your culture setup, go ahead and look out for these white colonies. The urogram stain, the uroxidase. So it is a great medium for Pseudomonas aeruginosa. And that, my dear audience, is the end of this episode. I hope you enjoyed listening about PEA and its uses and what you should be looking out for, and how great it is for Pseudomonas aeruginosa. I enjoy sharing this information with you. I think it's especially helpful for students out there, for brand new techs that are still getting familiarized with their media. So go ahead and keep that in mind. Always educate yourself. Learn the components of the testing that you are doing. It will make you better at your job. This is something that we as technologists can do, and you don't need to rely on your supervisor or your director. Educate yourself. It will make you stronger and better at your job. And I will continue talking more about things that you can use in the next episode. In the meantime, stay motivated, stay safe, and of course, continue talking micro. Until the next time. Bye.